Now, let's discuss about quadric surfaces of three variables. There are few types of quadric surfaces of three variables such as paraboloid, ellipsoid, and cone. Now, let's put our attention in understanding on how to sketch quadric surfaces of three variables, which is paraboloid. As you can see from the slide, this is the general equation of paraboloid, such as x squared over a squared plus y squared over b squared is equal to z over c. So let's learn on how to sketch paraboloid. Okay, let's say the question give to you z is equal to x squared plus y squared. How do you go about this expression or equation given to you? So basically, there are several steps involved when you try to sketch a paraboloid. The first one, you have to make sure you know how the surface looks like when you look it at z-axis. Okay, let me write. Look at surface from z-axis or a plane view. So when you try to look at your surface at z-axis, you will map your surface from 3D onto xy plane in 2D. So in this case, right after that, you have to look at your surface from y-axis. When you try to look at your surface or your paraboloid at y-axis, you will map your surface from 3D onto z plane in two-dimensional coordinate system. And the third one is look at your surface from x-axis. So when you try to look at your surface from x-axis, you will map your surface from three-dimensional coordinate system onto yz plane in two-dimensional coordinate system. So by combining the curve that you obtain from these three steps, you should be able to construct your surface in three-dimensional coordinate system. So in this case, let's take a look at what will happen if you try to sketch the surface by using these three steps. Okay, step 1, when you try to look at your surface from z direction, as mentioned earlier, it will be mapped onto xy plane, and on xy plane z is equal to 0. So let z is equal to 0. When you let z is equal to 0, x squared plus y squared is equal to 0 will give you a point on xy plane. And then you go to step number 2. When you try to look at your surface from y direction or y-axis, it will be mapped onto xz plane, and you will know for sure that will give you y is equal to 0, because you try to look at your surface from y direction, and on xz plane there is no variable y, hence explain why we assume y is equal to 0. Then you will end up with z is equal to y squared. So not y squared but x squared. Z is equal to x squared. When you try to sketch z is equal to x squared in two-dimensional coordinate system that involve variable z and variable x, you will know for sure that it will give you a parabola with a smile shape. When this happens, you continue with step number 3 And step number 3 did inform you to look at your surface from x direction or x-axis. Your surface from 3D will be mapped onto YZ plane in two-dimensional coordinate system by letting x is equal to 0. The given expression will turn out to be z is equal to y squared. So when this happens, you try to imagine your curve in two-dimensional coordinate system where you will have z versus y. And when this happens, it will give you another parabola with a small shape. Okay, you will end up with another parabola. As mentioned earlier, by combining all curves you obtain from all 3 steps, you will end up getting a surface in 3D. Alright, so I try to sketch my plane first. Not plane, my axis that involve z versus y versus x. Okay. So this is your paraboloid. You will see that this paraboloid will be traced along variable z. Reason being, z is the subject of your equation. My next question to you, what will happen if you have y is equal to x squared plus z squared? Okay, when this happens, if you know that it will give you that kind of shape, you can sketch straight away without the need to go to all 3 steps. The 3 steps that I did before this just to give you reasons or just to guide you on how you getting this type of paraboloid. So when this happen, when y is the subject of your equation, you will know for sure that you will end up with a paraboloid, and this paraboloid will be traced along y-axis positive. So let me sketch it for you. So this will be your paraboloid. So you can roughly imagine what will happen if x is the subject of your equation. Okay, let's try to answer this question. Let's say I'm giving you x, not x squared, x is equal to 3 minus y squared minus 2z squared. What will happen if you are given with this question? Okay, let me show you the transition. Okay, so I'm going to sketch few axes. I will have z, y, and x. Alright. Okay, if I try to rewrite the equation into terms I'm familiar, I will get x is equal to 3 minus y squared plus 2z squared. Okay, let's try to sketch x is equal to y squared plus 2z squared first. So you will end up getting a paraboloid which will be traced along x-axis positive. And then this is when x is equal to y squared plus 2z squared. So what will happen if you have x is equal to negative y squared negative 2z squared? Okay, let me improve my writing. Negative y squared plus 2z squared. So it will be reflected along x-axis. Then I will get a paraboloid something like this. And then right after that, what will happen if we introduce a constant out of sudden, which is in this case positive 3. So you have to be able to locate where x is equal to 3 first. So x is equal to 3, maybe somewhere over here. Okay, let's try to sketch x is equal to 3 minus y squared plus 2z squared. Okay, in this case, x is equal to 3. Why did I choose 3 along x-axis positive? The reason being, x is the subject of the equation, therefore, the constant 3 belongs to variable x. So this is where x is equal to 3. So right now, I will know that I will end up getting a paraboloid, and this paraboloid will look like this. Okay, you see the transformation from x is equal to y squared plus 2z squared, and then x is equal to negative y squared plus 2z squared, and then followed by x is equal to 3 minus y squared plus 2z squared. So this is how you sketch a paraboloid. So I hope if you can understand the concept over here, even though I try to throw what type of question, if you are able to pick up the knowledge or the tricks involved to sketch the paraboloid, you should be okay when I give you any type of question regarding paraboloid. Now, let's discuss on how to sketch quadric surfaces of 3 variables, which we call it as ellipsoid. So basically, this is the general equation that represent ellipsoid, such as x squared over e squared plus y squared over b squared plus z squared over c squared is equal to 1. When you are given with this general equation, this general equation is representing ellipsoid, where the value of the denominator are not equal. If A is equal to B is equal to C, you will end up with sphere instead. Okay, right now, let's discuss how we can solve this equation, which the question or the author asks you to sketch it in 3-dimensional coordinate system. Okay, for x squared plus y squared plus 4z squared is equal to 16. Alright, you have to divide the whole equation with 16 so that it somehow close to the general equation. And in this case, divide by 16, you will end up getting x squared over 4 plus y squared over 16 plus z squared over 4 is equal to 1. So the steps which I have explained when we try to sketch paraboloid will be applied when you try to sketch an ellipsoid, which is all 3 steps, such as you have to view your surface onto xy plane, yz plane, and xz plane. Okay, let's try to solve it according to the step. Okay, step number 1, you have to let z is equal to 0 because you try to observe your surface along z axis or z direction. So in this case, you will end up getting x squared over 4 plus y squared over 16 equal to 1. So in 2-dimensional coordinate system that involve x versus, not x, that involve y versus x, you will end up with an ellipse, and this ellipse will be measured along y-axis since b is greater than a, such as 4 obviously greater than 2. So that is the first step. Step number 1. Let's continue with step number 2. Let's continue with step number 2. You have to let y is equal to 0. By letting y is equal to 0, x squared over 4 plus z squared over 4 is equal to 1. So in this particular expression, we sketch it on two-dimensional coordinate system that involves z versus x. I will end up getting a circle. Okay, so I will get circle for this particular question. And then let's continue with step number 3. You have to let x is equal to 0 because you want to observe your surface from 3D onto YZ plane. That's why you let x is equal to 0. So when this happens, you will get y squared over 16 plus z squared over 4 is equal to 1. I will end up getting a two-dimensional coordinate system that involves z versus y. So in this case, I will get something like this. Then by combining all curves I have obtained from these three steps, I will end up with a paraboloid. Okay, so let's try to see for 2, 2, 4. So okay, you will get something like this, and the paraboloid obviously looks like a rugby ball. Okay, so this is how you sketch the ellipsoid in three-dimensional coordinate system. So I really hope you can do a lot of exercises just to get yourself familiar with how to sketch ellipsoid, because the expression will remain the same. Now let's put our attention on how to sketch quadric surfaces of 3 variables, but this time around we will sketch cones. So this is the general equation that represent cones in three-dimensional coordinate system, which is given by x squared over a squared plus y squared over b squared plus, not plus, but equal to z squared over c squared. Okay, the thing that differentiate general equation that represent cones with general equation that represent paraboloid, the subject of the equation for cones is to the power of 2. Meanwhile, the subject of the equation for paraboloid is to the power of 1. Alright, now let's discuss how cones are formed when you are given with this equation z squared is equal to x squared plus y squared in 3D. Okay, the question asks us to sketch z squared is equal to x squared plus y squared in three-dimensional coordinate system. So in this case, when you try to look at your surface from z direction, okay, we will apply the same steps which we have used when we try to sketch paraboloid and also ellipsoid, which is the three steps. Step number one, you have to look at your surface along z direction. So you have to let z is equal to 0. So when you let z is equal to 0, you will end up getting a point such as the point is represented by this equation, x squared plus y squared is equal to 0. It will obviously give you a point. Okay, there should be no problem with that. So let's continue with step number 2, which is you have to observe your surface from 3D onto xz plane. So in this case, you will let y is equal to 0. So when y is equal to 0, you will get z is equal to x squared. Z squared is equal to x squared. Z is equal to x. So you will get z versus x. Okay, you will end up with a straight line. And then let's move to step number 3. Okay, step number 3, you try to observe your surface along x direction. So it will be mapped onto yz plane. So when that happens on yz plane, there is no variable x. So you can assume x is equal to 0. So z squared is equal to y squared. Z is equal to y. So when this happens, you will sketch z versus y, and it will give you another straight line. By combining all curve you have obtained from these 3 steps, you will end up with a cone. Z versus y versus x. Okay, let me sketch all the lines. Okay, you will get these double cones, and these double cones lies along z-axis. The reason being z is the subject of your equation. So you can see that the upper part of your cone is represented by this expression, z is equal to plus z x squared plus y squared. Meanwhile, the lower part of your cone is given by z is equal to negative x squared plus y squared. Okay, what will happen to the equation of cones if you are given with this equation, such as y is equal to 4 plus z x squared plus z squared. So whenever the expression or equation given to you somehow involve Z notation, you should know that it will give you surface that looks like cone. So when that happens, pay attention towards the subject of your equation. In this particular question, y is the subject of your equation. By right, the cone will be traced along y variables. Okay, as what I did with the previous example, I'm going to sketch few axes. Okay. Let we observe the transformation. Okay, so right now, for x is equal to z positive set x squared plus z squared, it will give you not x but y. So y is equal to positive set x squared plus z squared. So when this happen, you know that you will end up with a cone, and this cone is positive cone, and this positive cone will be traced along variable y. So when that happen, so it will be along y axis. Alright, and then right after that, you, in the expression given to you, there is a constant 4. So this constant 4 will lies along y axis. Okay, again, the only valid reason why we have to put 4 along y axis is that y is the subject of your equation. Therefore, 4 belongs to the subject of the equation. In this particular question, y is equal to 4. Therefore, you will see that you will end up with a cone, and this cone move along y is equal to 4 unit on y axis positive. Okay, let's try another question. For example, x is equal to -5 negative set y squared plus 3z squared. Okay, again, when you are given with this question, let's try to sketch another. Okay. Right. So for this question, x is equal to positive y squared plus 3z squared is given by this question. So you will end up getting a cone, and this cone will be along variable x. Positive, yeah? And then right after that, x is equal to negative set y squared plus 3z squared. You will end up getting the cone, and this cone will be reflected along x-axis. So it will be somewhere over here. Okay, when that happen, and out of sudden, you will see that you will be introduced with constant 4. Not constant 4, constant -5. So -5 minus set y squared plus 3z squared. So you have to locate first where is -5. So this is -5 somewhere over there. So your cone will be traced along variable x, and it will move 5 unit at x-axis negative. So if you can relate my explanation through what I have sketched over here, so I really hope that if I give you any question related to cone in 3-dimensional coordinate system, you should be able to relate it with what you have observed or witnessed throughout this explanation. Alright, so I believe that's all for quadric surfaces of 3 variables. As mentioned earlier, we do have few example exercises, practices, and class activity in the slide presentation. If you do a lot of exercises by right, it will trigger to your mind on how to sketch the surfaces in 3-dimensional coordinate system. So I hope you can do the exercises on your own, and don't forget to always contact me if you have any problems, and see you again in another video. Bye.